This is Module 6, Section 2.1. We're going to look in this section at solving linear equations using properties of equality. Specifically in this section, we are going to emphasize the addition property and the subtraction property of equality for solving linear equations. And we're also going to introduce and look at opposite operations. Solving linear equations. Earlier in this module, we discussed that if a number makes an equation with a variable into a true equation, then that number is said to be a solution of the equation. For example, if we're looking at the question, is 8 a solution for the equation x plus 3 equals 11? The answer is yes, because if you take that equation and you replace that x with an 8, you would agree with me that 8 plus 3 on the left-hand side does equal 11. And so you have 11 equals 11, which is a true statement, and therefore 8 is a solution to that particular equation, because you get a true equation. However, what if you are not given a number to try? How do you determine what value or values of x, or whatever variable is in the problem, remember it doesn't have to be an x, it could be a y or a z or an a, are solutions? That is, what we're really asking is, we want to solve for the variable. So to do that, we're going to introduce something called properties of equality. Now there are 4 basic properties of equality. In section 2.1, we're going to emphasize the first 2 properties, but we're going to introduce all 4 here and then we'll review as we need to. So property number 1 says, if you have any equation, and we're just going to use a general representation here. For example, if A equals B, then property of equality number 1 says, then A plus C equals B plus C, which simply says if you have any equation and you add something to the left-hand side, as long as you add the same thing to the right-hand side, you should get a true statement and the equality remains true. For example, we'll use a very simple example. Let's say you're looking at 5 plus 3 equals 8. You agree with me that that is a true statement. And for whatever reason, you decide to take that equation and add, let's say, 2 to both sides of that equation. Now, if you add the same thing to both sides, this is representative of C in that rule. On the left-hand side, you'd get 5 plus 3 is 8, plus another 2 is 10. Right-hand side, 8 plus 2 also is 10. You agree that 10 is equal to 10. We have a true statement, and that side does check out. So if you add to one side, add to the other side, you still have an equation that is true. Property number 2 is very similar, except now, instead of adding, we're going to be subtracting something from both sides. So again, if A is equal to B, then A minus C is also equal to B minus C. And remember that from pre-algebra, subtracting from a term is the same as adding the negative. In other words, again, if you're looking at, let's say, 5 plus 3, which of course is 8, and then you change that into a subtraction problem, you've got, let's say, 5 minus 3 is 2. 5 minus 3 is the same as changing that subtraction to addition and changing the sign of the term that follows that to a negative. 5 minus 3 is the same as 5 plus a negative 3. In either case, you get 2 on both sides. Same answer. Basically the same problem, you're just changing it into an addition problem. So property 2 could be thought of as property 1 in terms of adding a negative. So if you add to both sides, you get the same thing. If you subtract from both sides, you get the same thing as well. And those 2 properties are what we're going to emphasize in this section. Property 3, as you would imagine, deals with multiplication of both sides. If A is equal to B, then A times C does equal B times C as long as you multiply both sides by the same amount. And finally, property number 4 says if you have any equation, if you take that equation and you divide one side by a value, as long as you divide the right-hand side by the same, you will still get a true statement. Remember that division is the same as multiplying by the reciprocal. And just to demonstrate that, let's say you had 12 divided by 6, we'll say. 12 divided by 6 is 2. That's the same as saying 12 times, instead of dividing by 6, we're going to multiply by its reciprocal. The reciprocal of 6 is 1/6. 12 times 1/6 is the same as 12/6 if you want to think about it as a fraction, and that of course is still equal to 2. Same answer either way. So division is the same as multiplication by the reciprocal. So we want to use properties of equality to isolate the variable on one side of the equation with constants on the other. So our goal is to get our x or our y or our z by itself on one side of the equation. To isolate the variable, we're going to use opposite operations. Now, opposite operations, there are a variety of opposite operations in math. We're going to look at the two basic operations, where addition is the opposite of subtraction and multiplication is the opposite of division. So to give you an example of what we mean by opposite operations, let's say that you had 3 plus 6. 3 plus 6, of course, is 9. Okay? And then let's say you wanted to undo that or take the opposite of that. In that example, we took 3 and we added 6 to it. If you take that answer, which is 9, and subtract, because subtraction is the opposite of addition, if you subtract 6 back off of that answer, you get back to what you originally started with. 9 minus 6, of course, is 3. So here we started with 3 and we added something to it. To get back to our original problem, we subtracted what we originally added because they're opposites, and we end up with the same answer. And multiplication and division are the same way. If you multiply a value by something and you want to get rid of that, then you would divide the same answer back out, and you would get back to your original statement. So addition and subtraction are opposites. Multiplication and division undo each other as well. So for section 2.1, we are going to concentrate on the first two properties of equality. They were, if A equals B, then A plus C equals B plus C. And if A equals B, then A minus C equals B minus C, which again is simply saying if you do something to one side of an equation, you need to do the equivalent to the opposite side in order for the two sides to remain equal. Again, we want to use properties of equality to isolate the variable, and that's the key. We're looking to get that variable by itself, isolate the variable on one side of the equation with constants on the other side. To isolate the variable, we're going to use opposite operations to move stuff around. So if something is being added but we want it on the other side of the equal sign, we'll subtract it. If something is being divided on the variable side and we want to move it, we'll multiply it to both sides. For this section, we will only need to remember that addition and subtraction are opposite of one another. So let's start with an example. Let's say you're doing a problem and the instructions say solve x plus 5 equals 11 algebraically. Now that's an equation that you probably don't really need algebra to solve. You can probably do that one in your head. But we're going to assume you can't and talk about the steps to solve it algebraically so that for those equations we can't solve in our head, just using logic, we'll have techniques that will allow us to solve any equation. So we want to get x by itself. We want to isolate the variable. So to get rid of the positive 5 on the left-hand side, we need to subtract 5 or use the opposite operation in order to get that x by itself on the left-hand side. However, you need to subtract from both sides of the equation because of properties of equality. properties of equality says, from the previous slides, that if you're going to subtract something from the left-hand side, you must subtract the same value from the right-hand side. So here's our original equation, x plus 5 equals 11. We want to isolate our variable. We want to get that x value by itself, so we need to get rid of that plus 5 and move it to the right-hand side. So the opposite of addition is subtraction, so you can see here we're subtracting 5 from the left-hand side. Properties of equality, though, says you need to subtract 5 from the right-hand side as well. On the left-hand side, 5 minus 5 gives us 0. So now the left-hand side says x plus 0. Do the math on the right-hand side. 11 minus 5 is 6. Anything plus 0 is itself, so x plus 0 is x on our left-hand side. Right-hand side, of course, says that x equals 6. And since we have our variable isolated, that is our solution. X should be equal to 6. Now the next thing is also very important in algebra. You always want to check your solution in the original equation to make sure that you didn't make a mistake. And you want to check it in the original equation before you messed with it, just in case you made a mistake in an intermediate step. So always check in the original equation. So take the original equation as written, take your solution that you got when you solved it, in this case x equals 6, and we're going to substitute that value in for x in that equation. So we think x should be 6, so our left-hand side now becomes 6 plus 5 equals 11. And do the math on the left-hand side. 6 plus 5 is 11. 11 does equal 11, so that's okay. Checks out. We can be confident that that solution is accurate. All right, so let's do the same thing with this problem here. We've got c minus 11 is equal to 22. Our goal is to isolate that c, so we have to move that minus 11 to the other side of the equation. The opposite of subtraction is addition, so we're going to add 11 to both sides of the equation, add 11. And I'm going to choose to use the column method simply because I think it's easier to work with. And always line up like terms. You want to add and subtract like terms, so I wrote the 11 underneath the 11, not underneath the c, because it's easier in terms of bookkeeping. So on our left-hand side now, our c is still there. Negative 11 plus 11 ends up being 0. So either plus 0 or minus 0, it's the same thing either way. Right-hand side, 22 plus 11 gives us 33. And anything plus 0 is itself, so we've got c equals 33 on our right-hand side. That is our solution. But we always want to check our answer, so always check in the original problem. So we've got c minus 11 equals 22. That's our original problem. We're going to put 33 in for c and see if our two sides truly are equal. So we've got 33 minus 11 equals 22. Do the math on the left-hand side. 33 minus 11 is 22. 22 equals 22. Looks good. Checks out. I think we can be confident that we have the correct solution there. Going back to the original problem here, a shorthand way, as you get more used to this method of doing this problem, is when you notice that something is going to completely cancel out. For example, the minus 11 and the plus 11 gives us a 0. You don't have to write that c plus 0 step unless you want to. You could just cross out the minus 11 and plus 11, recognizing that gives you 0 on the left-hand side and that that is gone, and you just have c left on your left-hand side. All right, so let's do another problem. Here, solve for q. 41 equals 45 plus q. Okay, we're trying to solve for q, so we want q by itself. If we want q by itself, that means we need to move that 45 to the other side of the equation so we can isolate the variable. If it bothers you that there's no operation in front of the 45, recognize that by the commutative property of addition, 45 plus q could be rewritten, if you want to, as q plus 45. Now that's not necessary, you don't have to do that, but if that makes more sense to you, you certainly can. Now you've got an operation to look at over here. We've got addition of 45. The opposite of addition is subtraction. So we're going to subtract 45 from both sides. That gives us, on the right-hand side, 45 minus 45, which is 0. So you can either write the right-hand side as q plus 0, or if you want to do a shorthand notation, positive 45 and negative 45, 45 minus 45 is 0, and those cancel themselves out. So that's a shorthand way to write that same thing. Left-hand side, do the math. 41 minus 45 is negative 4. And on our right-hand side, because we've got that q now isolated, that's our goal. Isolate your variable. That is our solution. Q is equal to a negative 4. As always, you want to check your answer in the original problem. So the original problem, before I messed with it, was 41 equals 45 plus q. We're going to put negative 4 in for q. So now we've got 41 equals 45 plus a negative 4. Do the math on the right-hand side. 45 plus a negative 4 is 41. 41 equals 41. Looks good. Checks out. Think we have the right solution. Okay, another problem. 14 plus x equals 9. Again, we're trying to get x by itself. Isolate your x. So if we look at this 14, again, there's not an operation in front of it, but if you are trying to move that, just look at the sign ahead of it. We know that that is a positive 14, so to get rid of that positive 14, we're going to subtract it from both sides. Another option, if you want to, is if you'd rather just change the order, 14 plus x is the same as x plus 14 on the left-hand side. And you certainly could do it like that. And again, here, it should be obvious that the opposite of addition is subtraction. So either way, you end up subtracting 14 from both sides. 14 minus 14 is 0, so you can put the 0 in if you want to, or you can skip that step. Do the math on the right-hand side. 9 minus 14 is negative 5. And so we have, as a solution, x equals negative 5 for this particular problem. As always, you want to check your answer in the original problem. So 14 plus x equals 9 was the original problem. We're going to put in negative 5 for x because we think that's our solution. Do the math on the left-hand side. 14 plus negative 5 is a positive 9. Looks good. Checks out. I believe we have the correct solution. Let's look at this problem. Negative 9 plus y equals negative 50. Okay, a couple of ways you can approach this problem. Your goal is to isolate y, get y by itself. There's not technically an operation in front of that negative 9, but if you look at the sign, the opposite of a negative 9 is a positive 9, so we are going to add 9 to both sides of that equation. Alternatively, if you want to, you can rewrite that left-hand side using the commutative property of addition. Negative 9 plus y is the same as y plus negative 9, if you want to change the order there, is equal to negative 50. Here, adding a negative 9 is the same as subtracting negative 9, which is kind of awkward. But remember, subtracting a negative is the same as adding a positive. So over here, you're adding 9. Either way, you end up adding 9, depending on which way you like that better. Negative 9 and positive 9 is 0. So on the left-hand side, we're left with y. Right-hand side, negative 50 plus 9 is negative 41. And that is our solution there. Check your answer over here. The original problem was -9 plus y equals -50. We're going to put in -41 for y, so -41 equals -50. Do the math on the left-hand side. -9 and -41 is -50. And those two sides are equivalent. Checks out. Looks good. Note the properties of equality can be applied to fractions and decimals as well as to integers. Now, farther down the road, we're going to talk about some special techniques for solving equations that have fractions and decimals. But for this case, we're just going to leave fractions as fractions, decimal as decimals, and just use properties of equality and opposite operations to solve those. So here, and sometimes I'll put down a vertical line just to remind myself that I have two separate sides that I have to either add to both sides or subtract to both sides. That's just a paperwork thing, totally up to you. So here, a plus 1/2 equals 3/4. Our goal, as always, is to isolate that a. So we have to get rid of that plus 1/2, which is on the same side. So the opposite of addition is subtraction. So we're going to subtract 1/2 from both sides. This is the one exception where I don't like the column method. With fractions, I don't like to try to add or subtract fractions, especially if they have different denominators, in a column method like this. So you'll notice that I'm now going to rewrite my right-hand side in a horizontal fashion simply because it's my preference to work with fractions left to right instead of in a column method. Left-hand side is the same way. Positive 1/2 and negative 1/2 ends up being 0, and I'm simply left with a on my left-hand side, which is my goal, to isolate my a. My right-hand side, I now have 3/4 minus 1/2. And we know that when we subtract fractions or add fractions, we have to have a common denominator. So if I look at my denominators in this problem, the least common multiple of 4 and 2 is 4. So I'm going to have to build up my second fraction by multiplying top and bottom by 2. So now on my right-hand side, I have 3/4 minus, do the multiplication, 2/4. Subtract the numerators, 3 minus 2 over that common denominator, and I get an answer here of 1/4. So my final answer for this problem will be, and I'm going to bring it up here because I'm running out of room, I have a is equal to a positive 1/4 as my solution. To check your answer, take your original problem, so a plus 1/2 equals 3/4. I'm going to put that 1/4 in for a. So now I've got 1/4 plus 1/2 equals 3/4. This is my check. I need a common denominator, so I need to multiply top and bottom here by 2 for that second fraction. Now I've got 1/4 plus 2/4 equals 3/4. And if I then do the addition on the left-hand side, 1 plus 2 is 3/4 on the left-hand side. That's the same thing I have on my right-hand side. Looks good and checks out. So fractions work exactly the same as integers in terms of opposite operations and properties of equality. Okay, here's an example with a decimal in it. We've got y minus 8.6 equals 2.5. I want to isolate that y. So the opposite of subtraction is addition. I'm going to add 8.6 to both sides. Minus 8.6 and plus 8.6 is 0. Y plus 0 is just y. So my left-hand side does have my y isolated. On my right-hand side, 2.5 plus 8.6, you can either do that by hand or you can put it in your calculator. I think you should find that that ends up being 11.1, and my y is isolated, so that is my solution. To check that answer in the original problem, I'm going to put that 11.1 in for my y. So I've got y minus 8.6. The question is that really equal to 2.5? That's my question in a check. Do the two sides really equal when I put that value in for my variable? Left-hand side, 11.1 minus 8.6 is indeed 2.5, and 2.5 equals 2.5. Looks good, checks out. Looks like we got the right solution. Now you may need to simplify the equation before you solve. You want to use the distributive property to clear any parentheses. Combine any like terms that are on the same side of the equation. So let's look at this example here. We've got 4x minus 3 minus 3x equals 5 minus 2. Now I'm going to draw my vertical line here because it's important to remember that when you're combining like terms, you can only combine like terms that are on the same side of the equal sign. For example, you can combine this 4x and this minus 3x because they're both on the left-hand side of the equal sign. So let's do that. 4x minus 3x, 4 minus 3 is 1, so 4x minus 3x is 1x, or just x, because 1 times anything is itself. And then we still have that minus 3 over here, which is an unlike term, so you can't combine that minus 3 with that x. Right-hand side, these obviously are just integers, so we can do this operation. We can do the 5 minus 3, but we cannot combine the negative 3 on the left-hand side with the 5 and the minus 2 here, because the minus 3 over here is on the left-hand side and the 5 minus 2 over here is on the right-hand side. You cannot combine like terms if they're on different sides of the equal sign. You have to move them first and then you can combine them. So the only thing we can combine in terms of integers on the right-hand side is 5 minus 2. 5 minus 2, of course, is 3. So here we've got x minus 3 is equal to 3. Our goal is to isolate that x, so we're going to add 3 to both sides. Opposite of subtraction is addition. And our x is now isolated on the left-hand side. X is equal to 3 plus 3, which is 6. So there's our solution there. And then you would want to go ahead and check that answer in the original problem. For time's sake, I am not going to check that answer, but certainly that is something that would be a step that you would want to do when you're working on homework or practice problems on your own. So let's look at this problem. 4 times the quantity 2x plus 1 minus 7 times the quantity x minus 1 is equal to 2 minus 6. When you have grouping symbols here and you're trying to combine like terms and isolate a variable, you have to get rid of those groups. So in this case, we're going to use the distributive property to distribute both that 4 and that minus 7 throughout that group so we can remove those parentheses, and that's going to be our first step. So on our left-hand side, okay, distributive property says take that number out in front of the group and multiply it to each term. So starting with that first term, we've got 4 times 2x is equal to 8x, plus 4 times positive 1 is plus 4. Then we have to distribute that 7 too, and you want to distribute the sign with it in order to get your signs worked out. So minus 7 times x is minus 7x, and minus 7 times minus 1, be careful here, negative times negative is a positive, and 7 times 1 is 7. So again, negative 7 and negative 1 is a positive 7, and that's equal to 2 minus 6 on our right-hand side. Okay, I'm going to draw that vertical line to remind myself that I can only combine like terms on the same side. So I've got a couple of like terms on my left-hand side. I've got 8x minus 7x is 1x. 1x is just the same as x. Okay? And my right-hand side, I've got plus 4 and plus 7, which is plus 11. And my right-hand side, do the math. 2 minus 6 on my right-hand side is negative 4. So now I've got x plus 11 is equal to negative 4. I want to solve for x, so I'm going to subtract 11 from both sides. My 11's cancel out on my left-hand side, and I've got a solution of x equals negative 4 minus 11 is negative 15. And again, always a good idea to take that and put it back in the original problem for all the x values and check that. Make sure that value works. All right, let's look at these two examples then. Let's start with the one at the top of the page. We've got 3 times the quantity x plus 7 equals 2y minus 5. Get rid of that group by distributing the 3. So 3 times y is 3y. 3 times plus 7 is plus 21, and that's equal to 2y minus 5. Remember, you can only combine like terms on the same side of the equation, so although you might be tempted to try to now add that 3y and that 2y, you cannot combine them as written because they're on different sides of the equal sign. You have to move either the 2y to the left-hand side or the 3y to the right-hand side in order to get them on the same side of the equal sign to combine them. So for this particular problem, I'm going to choose to move the 2y, or my y term, to the left-hand side. So I'm going to subtract 2y from both sides. The reason I subtracted is because this 2y is positive and the opposite of addition, or the opposite of positive, is negative. So right-hand side, 2y minus 2y is 0, and the y term is gone from the right-hand side, leaving me with negative 5 on my right-hand side. Left-hand side, combine like terms. I've got 3y minus 2y is 1y, which is just y, and I still have that plus 21 on the left-hand side that I haven't moved. Okay, my goal is to get my y by itself, so I want to move that 21. So I'm going to subtract 21 from both sides. 21 minus 21 is 0. And on my left-hand side, then I'm left with y. Right-hand side, do the math. Minus 5 minus 21 is a total of negative 26, and that is my solution. Put that up in the original problem in your notes to check that, to make sure that that works. Okay, one more example for this section. Here we've got 13x minus 9 plus 2x minus 5 is equal to 12x minus 1 plus 2x. Combine like terms on the same side. So I've got a 13x plus 2x. 13 plus 2 is 15, so I've got 15x's. I've also got some integers. I've got minus 9 and minus 5. Minus 9 and minus 5 is minus 14. And on my right-hand side here, combine like terms. 12x plus 2x is 14x. And I also have that minus 1, which is an unlike term, so I can't combine it with that 14x term. All right, so I've combined like terms on the same side. Now I'm going to have to move stuff around. So I'm going to choose to get my variable terms on my left and my constants on the right. But remember, it doesn't really matter whether you choose to get the variable on the left or the right. Either way, the solution will end up being the same as long as you use properties of equality. So I'm going to move that positive 14x by subtracting 14x from both sides. 14x minus 14x is 0, and 0 minus 1 is just negative 1. My negative 1 is left. On my left-hand side, 15x minus 14x leaves me with 1x, or just x, and then that minus 14 is still there as well. So now I've got x minus 14 equals negative 1. I want to get x by itself, so I'm now going to add 14 to both sides. Minus 14 and plus 14 is 0, so I've got x isolated on the left-hand side. Right-hand side, negative 1 plus 14, or 14 minus 1 is 13. And that's my solution for that problem. Again, I will leave the check to you. You would want to take that 13 and put it in for all the x's in the equation to make sure that your math works out. So that brings us to the end of Module 6, Section 2.1 material. You should now complete the homework for Module 6, Section 2.1 found in MyMathLab, and when you have successfully completed the above homework, you may proceed to the Module 6, Section 2.2 video.